Okay, so in this video, we're going to look at the application of integrals in statistics. And in particular, we're going to try and find the probability that x takes some value between 0 and 1. Okay, and we're going to work with the given probability density function, and we're going to try and solve this problem. Okay, so the first thing to recall is that for a variable that is defined in some interval, okay, let's say some interval j, okay, the probability of over that integral is 1. So the area under the curve of this function is going to be 1, right? That's because if we assume that j contains all of the possible values of x, then the area under the curve is 1 over that interval, because it's certain that x will take some value in that interval, right? So if x is defined just over, if x has to be over some 2 points, let's say a and b, then the probability that x takes some value in here is 1, right? Because it has to take a value, and it has to be somewhere in between. Okay, so this is what we start with. Okay, so using this piece of knowledge, we can move on to try and solve this problem. Okay, so what we can say in this case is that, so we are given the interval that x is defined on, which is between 0 and positive infinity. So what we can say is that the integral, so in this, so just to be clear, in this case, this is j, right? This is j, okay, and a is 0 and b is infinity. Okay, so now what we can say is we can get the integral over 0 and positive infinity of c over x plus 1 cubed equals 1. Okay, so once we have that, now we can play around with this, right? Well, let me just dx equals 1. Okay, and so first this is a constant, so we can just take it outside the integral, which is 0 to infinity 1 over x plus 1 cubed dx equals 1. Okay, great. So now we can just solve this using our usual tools of integration. So let's go ahead and try first with substitution, right? Because that's generally the easiest thing to do if we can manage to do it. And in this case, we can notice that if we derive this inside function, we get a constant, and that's exactly what we have outside, right? So it's 1 dx essentially, right? So this is, it might make it a little more clear to look at this as, for example, this is just 1 times, so if I just, this is 1 times dx equals 1. Okay, it's the same thing, right? And what we're looking for is there some function that we can set as u, such that when we derive that function, that derivative already exists in our main function. And in this case, if we derive this part, we get 1, right? And we have a 1 out here, so that should be fine. So let's go ahead and do that. So let's let u equals x plus 1, okay, and then du by dx equals, this goes to 0 and this becomes 1, and du equals dx. Okay, right, so now we can substitute this value and this back into this equation. Okay, and that gives us, this is the same as c times infinity of u to the minus 3 du. Okay, so this is gonna be u to the minus 2, so minus 3 plus 1 divided by minus 2 times c evaluated between 0 and infinity. But we can't just use these two terms, use these bounds, right? Because this is in terms of u and these bounds are for x. So we can either get new bounds or just put the x value back into this function, which is, so we get c times 1 c times, well, u is x plus 1, right? U is x plus 1 to the power of minus 2 over minus 2, right? And then that's evaluated between 0 and infinity. Okay. All right. So now I'm just gonna bring this up. Bring this whole thing up here to make some space. Okay. Let's just rewrite this, right? So we have c times 1 over minus 2 times x plus 1 squared, right, from 0 to minus infinity. I just brought this down. Okay, right. So how do we evaluate this? Well, now remember that infinity is not a number, right? It's just this has to do with limits. So you can't just, you're not exactly just plugging in infinity here, right? But we can, but let's see how this works out. Okay, so first, the upper bound, the limit of this function as x goes to infinity. Well, as x goes to infinity, this behaves as, so as x goes, so essentially what we're doing in this situation. Let me just get a different color. Okay, so the limit of 1 over minus 2 x plus 1 squared as x approaches infinity. Okay, so we can sort of not worry about the constants, because at infinity this 1 is not very meaningful. So this behaves approximately as 1 over minus 2 x squared, right? And as x goes to infinity, this will go to 0, right? Because this gets infinitely large and this becomes smaller and smaller and smaller, goes towards 0. Okay, so that translates here, and you evaluate this is going to be c times this value, right? So 0, because that's the evaluation of this, and then 0 minus, evaluating this function at 0, we get, so 0 plus 1 is just 1. This is 1 times minus 2, so that's minus 1 over, this is 1, so minus 1 over 2, right, equals 1. Okay, remember this whole thing is equal to 1. Okay, now this is just minus a half, 0 plus a half, which is just c times a half. C times a half equals 1. Therefore, c equals 2. Right? Okay. Well, c equals 2. Alright, so now that we have c equals 2, now we can just plug this c back in here. So we get 2. So the probability of x equals 2 over x plus 1 cubed. Okay, so now we have this equation. So the first thing we had to do is solve for this c value, right? Now that we have this equation, we can use that to get the probability, to get the probability that we're interested in. Okay, so now So using this function, what we do is we get the integral of the interval that we're interested in, so which is just the integral between, let's say, 0 and 1. So this term, right? Okay, integral between 0 and 1 of px, right? Which is our number over here. Okay, right? Which equals the integral from 0 to 1 of 2 over x plus 1 cubed dx, right? And we can take this 2 outside, which is 2 times the integral of 0 and 1 over x plus 1 cubed dx, right? And we did this already. We already did this integration over here, so let's just use that result, right? So what do we have? So we get the integral of, so we have to get this integral at this new boundary, right? So this is the same as 2 times 1 over minus 2 x plus 1 squared evaluated between 0 and 1, okay? And that's going to be 2 times, plug in 1 here, this is going to be 2 squared, 1 plus 1 is 2, 2 squared is 4, that's minus 1/4, right? Is that minus 1? Yeah, this is 2 squared is 4 times 2, this is 8, sorry about that. This is going to be 2. 2 squared is 4, 4 times 2 is 8, so minus 1/8, plus you plug in a 0 here, this is just going to be minus half, right? So minus and minus half. Oops. Because you plug in 0, this becomes 1, this is minus half, right? Minus half. Okay, so minus 1 over 8 plus a half times 2, which is 0. Okay, and that's our final answer. So what we get is the probability that, x takes a value between 1 and 0 is 0.75. Okay.